It's Wednesday and it's time for Cataloging Cocktails. It's an honest, no BS, non salesy conversation about enterprise data management. I'm Tim Gasper, longtime data nerd and product guy, joined by co host Juan. Hey, Juan.
Hey, I'm Juan Cicada. I'm the principal scientist at Data.World, and it's Wednesday, middle of the week, end of Wednesday, and it's time to take a break and chat about data. I'm in a different place today. I'm in our office. I think this is the first we've done an episode, one or two here in
We
the
did
office.
one episode there, yeah, but you're in one of the quote phone booths, right?
Exactly. Yeah, we were gonna eventually actually create a cataloging cocktails room here at the Data.World office. So this is gonna be cool to go do that. And well, today we have a really cool guest, and this is a guy who if you don't follow him on Twitter, you better be following him on Twitter. I just love seeing everything that he is tweeting about because he's truly asking the hard questions. It's an honest, no BS guys. And this guy is Erik Bernhardsson. He's very well known. He's built the music recommendation system at Spotify. You ran and grew the tech team at better.com from 1 to 300, I think. And now you're working on something new. How are you, Erik?
Hi. It's exciting to be here.
Oh, it's a pleasure. Thank you so much for accepting the invitation. So, hey, before we dive into the real deal here, what are we drinking and what are we toasting for? You want to kick us off, Erik?
I'm drinking. I just grabbed some beer in a bodega on the way here. So I'm drinking Goose Island. I can't drink liquor at this time of day. It just I would like to fall asleep.
No, it's 5 o'clock in New York, right? So you should be okay.
It is, but I don't know. I'm old now. If I drink liquor, I have to go to bed within 3 hours.
How about you, Tim?
I am drinking a Scotch and ginger, keeping it kind of simple today. And for my ginger ale, I'm using Bundaberg. It's a Australian owned. I don't know if it's made in Australia, but Australian owned ginger beer. Pretty tasty. It's got a little bit of a funkiness to it, which is kind of interesting.
You went a bit fancy. I am actually, so I'm in the office and we have a bunch of whiskey and we had some Mexican whiskey, which is Abasolo. So I'm calling this the Mexican highball. So Abasolo whiskey from Mexico and Topo Chico. So that's my drink. So let's toast for, what do you want to go toast for? Erik, what are you toasting for?
I don't know.
Cheers to being old, but not too old.
Well, actually, so cheers to being old, but not too old, because we got our warm-up question today, which is going to show us that we're not old, because
maybe not old enough, huh?
Not old enough. So what's your favorite spaghetti Western movie? I don't know. I don't. I know. I guess I should watch one day The Good, the Bad, and the Ugly. But
I think that one is good. I feel like I watched it, but I don't know. I really don't know. You're asking.
So you don't watch any either, huh, Erik?
I don't watch anything. I just don't have time. I'm trying to start a startup.
We're not that old.
I don't know. I have zero time to watch anything.
Yeah, I was looking up what are examples of spaghetti westerns, and a lot of the names sound familiar. I was like, oh, A Fistful of Dollars. I've heard of that. Never watched it. Maybe I should.
Yeah, they're all made in Italy, right? That was the thing, right? Because
a bunch of them were made in Italy. Yeah, and it became just this style. They're so bad it's good kind of thing, right?
Oh, is that right?
All right, so now we know we got some homework. Eventually, one day we'll watch some spaghetti Western movies.
Movies.
All right, well, let's kick this off. So, hey, Erik, so there's so many data tools right now, and so many tools is exciting because, hey, there's a demand for this stuff, but this also means that a lot of tools out there are not kind of satisfying a lot of the needs. So, honest, no BS here. Which are the tools that suck and which are the tools that don't suck right now?
Yeah, I mean, I sort of hesitate to throw tools at it, but I'm kind of an anarchist. I think in a way, you should just let people use whatever tool they want. And the fact that they use that tool probably means it's good. People using things probably means they derive some sort of value from it, and so that tends to be for me what I look for. Do people enjoy these tools? So I think what's bad is I think how to what extent data teams are wasting so much time on infrastructure stuff, stuff that's not core business logic, and so if there's any tool I want to call out maybe as like bad, it would be like maybe Kubernetes, maybe like, I don't know, I feel like AWS is kind of annoying. All these like Terraform, Docker, like all that stuff. Like I just want to do like data. Like why do I have to like write YAML files? Like, I don't know. YAML. I'm gonna call out YAML. I hate YAML.
It's like a necessary evil at this point.
That's the point. It's a necessary evil. I think people hate it, but they love it. It kind of makes, I mean, you need something like it, I guess. But so here's the point that you're making, how I'm interpreting is, what sucks is all the pipeline, the infrastructure stuff. What I really want to go focus my energy is on the business logic of actually doing things with data. And so all the infrastructure stuff is what sucks right now.
I mean, I like, look, I'm like sort of old enough that I've sort of been through a lot of like I've been doing this for many years, and 10 years ago, like everyone was doing Hadoop, and like Hadoop in a way was like quite good because it was like the first tool of its kind that let people operate on large data sets, and for that reason, I love Hadoop. But like, looking back 10 years ago, I also realized now like Hadoop is terrible in so many ways. Like there's so many more like efficient, so there's so many better ways today to work with data that's not Hadoop. And so to me, that's a question I ask myself a lot is like, what are the tools today that are like the Hadoops of tomorrow? Like what are the tools we're going to look back at in 10 years and say, actually, that was like really bad, but I guess we didn't have any options.
So, but what would, okay, so this is interesting. So at that point in time, you would say this was a good tool, but then 10 years later, you're like, well, this is kind of a bad tool.
Or maybe an exciting tool versus then becoming a bad tool.
Yeah, I mean, like I think like tools often start out as like enablement. Like they're like, the first version of every, tool in the tool chain is always like a thing that like lets you do things for the first time. And that's exciting. You're like, wow, like finally I can do like operate on large data sets. I can train deep neural networks. I can do whatever. And then like, incrementally, like, newer generations of that tool end up actually like transforming it from just like pure enablement to like actually making engineers productive. And they usually like lower the cost of operating on large data sets or whatever it is by like, multiple orders of magnitude. Like an Hadoop query that, 10 years ago would take me, a whole day to write and run. Now it's like a SQL query. I just like run it and I get an answer, right? And I think, so that's not to say Hadoop was like bad. Like I think, it was just like an example of like something that I was like, it's the first example of something that enabled me to operate on scale, at scale. But, over time, like progressively, like new tools came and just like lowered the cost of doing that by probably in like 2 orders of magnitude. It's probably 100 times easier to just write a SQL query today in Snowflake or whatever and get an answer immediately.
Right. Hadoop's an interesting example because, when it first came out, everybody was like, MapReduce and Pig and Scoop. And like everybody was kind of getting excited about the initial ecosystem there. But then it very quickly kind of just iterated towards, actually, I just want to run SQL, right? I just want to run SQL on Hadoop. And there were like 5 ways to do it. And now there's really only one. And then AWS, hosted EMR and it got better and better. And so Hadoop kind of disappeared. It all went back to SQL sort of, right?
Yeah.
Does that, that cycle kind of repeat itself for these tools that kind of are exciting, but then kind of fade a little bit? Is that like, does it always kind of come back to common things like the warehouse and SQL and stuff like that? Kind of curious about what you're seeing where things are trending towards.
I don't know if it's like a cycle, but you're right that like something kind of happened where like in like 2005 or whatever, like all the enterprise companies were using like Oracle and like stuff like that. And like the startups, like they were like starting an experiment with like MapReduce. Maybe it's more like 2008, something like that, 2009. And so it was this weird thing where like all the startups were using Hadoop and all the like enterprises were using SQL. And then like Snowflake was like, we're going to build a better Oracle, sort of like a better, but like for data warehouse, for like OLAP type stuff. And so they built this tool. And then, I think it's like one of the rare examples where actually like adoption was like enterprise adoption was actually earlier than startup adoption, where, because startups kind of adopted this like bad thing, like in retrospect. And then like Snowflake, did a really good job. And eventually like they won over the startups too. I think it's it's actually kind of a rare example. I don't know. Maybe we'll like bounce back again. Like we've seen this a lot in history, specifically with SQL. Like that, there was 3 or 4 times in the history of SQL where people thought it was a really good idea to put business logic in SQL. Like a long time ago, like people were experimenting with stored procedures and triggers and like all this kind of stuff. And then we kind of realized it's kind of a bad idea to do that. So we started like taking out the business logic, and putting it in the app instead. And like the database was more like, this CRUD, like you just like read and like, so it's interesting on the backend side, that certainly happened. I don't know if that's going to happen on the warehouse side. Like, I don't know, like people are very productive in SQL, but I think there's an argument that like when I look at it, I'm like, yeah, a lot of people, like there's a lot of business logic in SQL. Is that the right place to put it? Like, I don't know. I'm not convinced, but like, I don't know. People like it. So I think that's an argument for it.
Let's dive into this, because the business logic is something that gets moved so many places, right? It's in triggers and views and stuff, and then we put into the application logic. But hey, I mean, putting all this logic in the application, you get not just the silos of data, but you have silos of application. People don't know what this stuff means at all. So now we're starting to go see things like DBT and putting a lot of the logic, the modeling, and these transforms inside of DBT, which eventually is just SQL. It's just SQL outside of the warehouse, but eventually gets connected somehow in the warehouse. So where do you see then the SQL, the business logic being implemented in a YAML file?
No, that would be like a disaster. I think that's like the worst.
That was a joke. Yes, you
Yeah.
can't see my face, but yeah.
No, I do. I think, I don't know. Like, I mean, like in a way, like I'm like the biggest fan in the world of SQL. I wrote like this like kind of long rant blog post like a couple of years ago that's like about how much I like hate random DSLs and query languages, and how I just want my SQL back. And then like a couple of years later, like now there's like SQL everywhere, and I'm like, oh, like let's take it a little bit slower. Like what's going on? So I don't know. Like I don't know. Maybe it's a good thing. Maybe it's a bad thing. I think having a lot of SQL is certainly better than having a lot of like bad query languages, for sure.
Well, we definitely see things get hyped, right? And so maybe now, the train left Hadoop station, it went to TensorFlow station for a little while, and now it's all on the SQL kind of train, right? And I've seen a lot of tools that are just like, dashboards. All you have to do is write SQL, and obviously DBT is now something that's really, really popular. It's kind of taking the world by storm right now. Even within this realm of SQL-oriented tools, are you seeing certain things that are more popular, are less popular? Are more useful, less useful? What's your kind of thought process there?
I don't know enough about that. Like, I mean, I know, like, Materialize, I think, is like building something incredibly cool. Like, I think, it's kind of a risky thing. Like, like Materialize, for the people that don't know, basically the whole idea is like you can build like incrementally materialized views. So the idea is like in SQL, you can define a view, and that gets like incrementally refreshed with new data, which I think is pretty cool. Like you can do a lot of like sort of real-time, data transformations using that. I think it's still like TBD. Like that's a lot of business logic again that we're putting in SQL. Like, is that a good idea? I don't know. Like I think so. I don't know. But Materialize is certainly like a tool. And full disclosure, I'm like a nominal investor in that company, and I know the CEO. But to other than that, I think there's a lot of exciting stuff. Like in general, like I am overall like pro SQL. I think it's still to be determined if. What I think is like important to remember too is also that like I think the demand for data is just like enormous, and so there's been this like interesting shift in the last 5 years where like basically like making data available on a SQL level has been like by far the easiest way to make it broadly accessible to people.
Mm-hmm.
I think kind of I'm also like quite bullish on code, and I think in a way like the fact that we've seen the pendulum swung so far towards SQL to me means like that's a reflection of like how large and like how desperate people are to work with data. Like they're like, I just want to like get data, like do stuff on it, and it's hard in code, so I'm going to do it in SQL instead. So I'm also very bullish on like code, like Python, like stuff like operating on data too. Like I think to me the success with SQL is maybe like less of like a reflection of SQL in itself, and just more of a reflection of people really want data, and SQL just ended up being, for now, like the fastest way to get people access to that data.
So what's interesting is that we've been talking for the last 10 minutes about SQL. I think this is some sort of this is evidence in a way that SQL has transcended the test of time, right? You
For
see these
sure.
cycles of like Hadoop was cool at that moment, then it goes down, right? Whatever's cool today, something is going to go down tomorrow. But SQL has been there forever. And one could argue then that SQL is a good, cool tool, even though it's old, it's been around for so long. It's just so valuable that so many people know it. What else is out there like SQL that you've seen? I guess there's like query languages, programming languages like Python and stuff. But what else would you include in this? Like the test of time that they've been around for so long and they will continue to be here.
C. I think C. I mean, like, how old are you know? I think SQL is like 67 or something ridiculous. Like C is from like 72 or something. They're both 50 years old. That's insane. And so you know, I don't know if you know familiar with this like Lindy effect. Like basically, it's sort of ideas like the longer something's been around, the longer it's probably going to stick around. So you know, when I look at like programming languages and whatever we're going to have in 50 years, I think we're far more likely to have C and SQL in 2061 than we are to have, not to like throw them under the bus, but just saying like R or Python or Julia or whatever, because and maybe it's a little bit unfair to like bucket them in the same thing. Like C is obviously a very different thing. It's a systems language, but it seems weird. But like when you think about it, like I think we're going to have a lot of people writing C in like 50 years, which is kind of crazy when you think about it. I could be wrong. Who knows?
No, I think I'm with you on this. I mean, we still have mainframes, and people there's still people need to go learn COBOL and stuff like that for stuff that exists for years ago.
Sure.
But it goes back to the comment you made earlier about adoption, right? It seems like the tools and technologies that get adopted are likely to be the ones that continue to see more adoption, right? And they kind of continue to see the test of time, and it's like a momentum thing.
I think that's right. I think there's actually another effect too, which is that I think, I was tweeting something about that this morning, actually. I think I've sort of also like increasingly been convinced that like there's a certain amount of like conservatism that's like good for programming languages almost. Like I think some languages are like so eager to like solve every new problem in like some new way. And then they just like get very bloated. Like I look at C++ and it's like, I can't use this. Is like insane. I'm a little nervous about Python. Like it's just, the surface area of the language is just like enormous these days. Like I've done a lot of like async IO in the last 6 months, and it's like it's a mess. Like it's like so complicated. I love Python. Like it's by far the language that I'm the most productive in. But there's just so much surface area today, and so I think that's another sort of interesting point is that SQL in a way. Part of why it's successful, maybe it's also because it hasn't really evolved much, right? Like there's a little like there's like JSON extensions and like stuff like that, but overall, like maybe part of its success is like it found this like very like conceptual integrity, like this like nice core in the 60s and 70s that solved the problem beautifully, and then it sort of just stuck to that. It just never tried to do all this other stuff.
I mean, frankly, it's a stable language, and it's very simple. If you think about SQL, right, it's grounded in this relational algebra, which is really very simple. You got tables that you apply some operations, and that generates a new table, and then you keep doing these operations over and over again. That's pretty much it. And I think I agree. SQL is just this beauty of a language because one, it's declarative, and I think that's something which is super important right now. That it transcends the test of time because it's something declarative, because it's something that it's easier to maintain, it's easier to go infer about. And I think when we go back to the issue of the business logic, you want business logic to be associated to a declarative language. That's my point of view. I think that's what we want to be able to, because that way we can very quickly trace things. You have the lineage, you know where things come from. It's easier to infer about it, to reason about it. So that's why I think it's super important to figure out how to go manage business logic in a declarative language. And yeah, that is going to be something like SQL. It may be something like a DSL, but I think SQL is always going to be something we're going to be using. And I think we should be pushing more of our business logic into SQL. That's why I'm a big fan of DBT. And I think this is something that will be around.
Yeah, I agree with like 80% of what you're saying. I think making sure things are declarative, I think, are quite important. I think SQL, despite its strengths, has many flaws. Like it's not modular. It's like hard to reuse things. It's hard. So there's many issues with SQL too, like that, where I think it could be much better. But you're right in the sense that I think like this sort of declarative nature is very, very useful. And my feeling is like also like languages like Python can be quite declarative if you just like, design it. Like if you sort of build frameworks and libraries in such a way. I've been playing around with Pulumi, which is like a very different application. It's about like defining infrastructure. And Pulumi is like you can actually define declaratively infrastructure in Python, and in the end, it sort of like does like a state diff between like what's there in the cloud and what's there locally, and then applies that diff. I guess React is like a similar way. Like JavaScript is not a declarative language. Or I think you could argue it's an imperative language. But React has this beautiful I think relational this sort of nice thing where sort of you declare what you want, and then the framework takes care of like making that happen inside the browser. So I don't know. I think there's a lot of interesting directions to explore.
So is the future then about finding higher levels of abstraction? Because if you think about being a declarative language in SQL, it's just a higher level abstraction. What you're just describing is more, I want to go define the what and not the how. Is that where we're seeing a trend? Is that where the next cool, good tools are going to be that will probably transcend the test of time?
I think
I don't
so. I think so. I mean, I think that's always like beneficial. Like you want to express like the what, not like the how, right? Like that's and in SQL the query engine takes care of that.
Exactly.
And so I think that's true.
So what do you think about all this low code and no code?
I think it's fine. I mean, like I think I have a similar view on low code and no code that I sort of expressed earlier, which is that to a large extent, I think it reflects the extreme demand for software that exists in the world today, and that people are so eager to build software that they want whatever tool needed. And like one like very crude, reductive way to think about like what is a software engineer? Like a software engineer, I think is actually just their job is to take business logic. Their job is to take business goals and express them as like business logic, and programming languages are kind of just like one concise way to like express business logic. So I think you're always going to need people who are trained at like taking like a fuzzy objective and then like kind of think through all the edge cases and like how do you like make it into like logic, and that's just unavoidable as a problem. Like I think you're always going to need people to like think through all the edge cases and all the things. To me, that's what a software engineer does. Right. And so, that's why like, with no code or low code, like you don't really escape those problems. You just like push them somewhere else. And so I think, what I think we're going to see is like a lot of companies adopting those tools. That's great to get started. But like in the long run, they're just going to reinvent software engineering. And then they're going to realize, actually, we should just hire software engineers to take care of this. Because like now we have, a billion trillion edge cases in this, now we have to maintain this YAML file, and it's like really hard. And like, I wish there was a way to debug it, and I wish there was a way to test it. And like, a software engineer comes in and they're like, yo, actually, we kind of figured it out. It's called unit testing. And by the way, we have this cool thing called Git, and we have this like cool thing, where we do continuous integration and like pull requests, and everyone's gonna be like, wow, like, is that, and hopefully by that time, like we'll have like even better programming languages for expressing logic. And so I don't know. I think to me, like the success of low code and no code in a way is a good sign if you're a software engineer, because it means like the demand for your services is going to be even higher in the future.
So you mean that if no code, low code is successful, they were going to start building big or creating new holes that need to be filled in. So they're going to just have to go hire more software engineers. So software engineers will always, I think they're always going to be in demand, but there's going to be higher in demand.
Yeah, I think that's right. And it's not like they're going to have to fix all the like problems caused by like low code and no code. But I think I'm just saying, I think that, success of low code and no code is to me a sign that the demand for software is very high. And I think to some extent also, I think, when I think of no code and low code, I think the ones that are going to be successful are also the ones where engineers want it. Like there's many tools that are like built in order to go around software engineers. Like you see this very commonly in like marketing teams. Like marketing teams are like, oh my God, like it's so hard to launch a campaign. I just want a tool to do it myself, like whatever, like do an A/B test or something. And then, but I think, to some extent, like that speaks to like an organizational dysfunction where like in reality, like the best ways to solve it is to like embed software engineers with the marketing people, call it a growth team. And then like, have tools that, both the marketing people and the engineers can work with at the same time, whether it's like Iterable or like Figma on the design side, or whatever it is, like tools that like everyone likes and that engineers, like because they can extend it in code, but also like that business people like because they could just like see things inside them. And so I think, that's what I think is like the future of all these things.
I like that perspective. It kind of gives you an idea of like, because as a product manager, I get excited sometimes about low code, no code tools. Like for example, about a year ago, what's that company called? Bubble.com or Bubble.io or whatever. They let you basically build your own application WYSIWYG style. And I was like, wow, this is so cool. But it's like an example of a tool that goes around software engineering, right? And so the second that you're like, hey, I really want to like build this really big, robust application, then you're like, I kind of locked out the engineers when really I want them to be part of it. And I think that's where things like DBT or things like Dagster or things like these types of tools that kind of are like, oh, let's bring visual aspects. Maybe we're even evolving to some no code aspects in the future. But in general, these things really embrace software and code as a core sort of thing. It's nice to see tools that can do both these things.
Yeah, for sure. And I think the key to success for a lot of these tools is actually like bridging the gap between different business functions that previously didn't work together. And I think, by doing that, you actually sort of lock in, like your vendor locking gets even tighter. Because if you have like two different functions that both want to keep a tool, that's like exponentially harder to get rid of it in a way.
Right.
Whereas if it's something
the thing that
like,
binds us together.
Yeah, exactly. And so, those tools I think are going to see a lot of success.
So to take us back to tools again before we kind of go and into a slightly different direction, there's a lot of different parts of the data stack. And, Juan and I were really curious, what is like the Erik Bernhardsson, modern data stack or preferred data stack or whatever, right? Like if you had your canvas of data tools, what are you pulling together? What's your CI tool? What's your data warehouse? And feel free to give multiple options if you don't want to pick favorites, but like, curious as to what your vision of the stack is.
I think it's funny because like every startup has like a blog post today and they're like, here's the new modern data stack. And by the way, we're like this big box in the middle.
my company is the big box, right?
And then there's like, we're right next to DBT because like everyone loves DBT. So they're like, here's like our startup. And then like right next to it's like, oh, it's DBT. And then there's like Fivetran. And then like there's like all these like ancillary things around it. They're like, yeah, this Airflow of, whatever over there. So I don't know. I think the modern data stack, like I'm like increasingly skeptical that it exists. Like I think it's just like whatever people want it to be. Like it's like Rorschach blot, like you just like see whatever you want to see in it. So I don't know.
I guess
like,
I'm asking you, what do you see when I show you the ink blot?
I think I see a lot of boxes. And the question to me is like, I don't think anyone is happy with that fragmentation. Because, if you're a customer, if you're a company that works with data, like, do you really want to bring in like 35 different tools and like duct tape them together?
Exactly.
Like, and, especially if you're an enterprise company, do you want to go through 35 procurement processes? Like, certainly not. And so I think, sort of, I know I'm kind of dodging the answer to your question, but I think to me, like, at least like, we're probably going to see a lot fewer boxes on that. And I think, over time, there's going to be a lot of consolidation in this space and like a lot of, tools like taking over adjacencies and doing multiple things over time. And so that's a trend I think we're going to see a lot of.
So I want to push. I want to push on this because you are dodging the question, but you just said about consolidation. So, what is being consolidated into what types of buckets? And that way, let's see if we can figure out. You can actually answer that question.
I mean, I think the best example is like Databricks, right? Like Databricks is trying to do, they start out with the query engine, but now they try to do a data warehouse, they try to do data lineage, like all this other stuff, right? So that's a clear example of a vendor trying to do a lot of stuff. And I think we're going to see a lot more of that.
Do
Okay,
you see that as a good thing?
I think so. I mean, I think, like good, like I think it's like economically like the inevitable outcome here, because as a vendor, like like you want to be able to cross sell and like subsidize your CAC, or sort of amortize your CAC over multiple products, like, and as a company, like you kind of don't want to deal with like 35 different vendors, like I said. So I think over time it is a good thing. I think maybe like altruistically on the bad side, like is it good that vendors get sort of quasi monopolies over the data stack? No, that's probably not that good, because like what if they stop innovating, turn into an Oracle and like whatever, just like charge people like humongous amounts of money? I think that would be bad, but I don't know. I think the startup world is like so dynamic today that like also like I don't know, there's so much competition, and I think it's for the better for everyone.
Now, I was today. I've had so many different conversations. I met this morning with Sarah Cantanzaro from Amplify, and then
All
I
right.
had, yeah. So she will be a guest in next year, and then I also spoke with Andy Palmer from Tamer early, who will be a guest in a couple of weeks. And this was the topic of, wait, there's so many different tools right now. I mean, look at this landscape that everybody is going to be like, do I need to go buy 35 different tools? No. And Sarah's argument is like, the problem actually going to be that I don't want to go through procurement. I don't want to go through the sales process of going again through all these tools. I literally do not have the time to go do that. Your engineering team is going to spend all their time going through these sales process, that can't happen. There will be consolidation over there. And talking to Andy was about, yeah, you have these oracles, these companies that were just this big monolith, but they stopped innovating. So then they have to go, they bring in the new thing. So on one side, we're like, well, you got the oracles of the world who are going to be the monolith, so you can do everything. And we're like, maybe the old school people think this is possible, but that's not really what's going to happen. But then we've taken it to the other extreme, and it's like, well, now look at Matt Turk's data landscape thing. I mean, this is ridiculous. So we've gone literally to the other extreme, and now it's just so much stuff. So where is that sweet spot? So what is the consolidation that's going to happen? And actually talking to Sarah earlier today was we're saying, okay, there's things around, don't quote me on this stuff, but it was like around metadata, around data, around workflow transformations, around analytics. And the thing is that when you look at these different buckets, not everybody will agree, well, hey, I want to be consolidated under this bucket or under this one, right? So this is going to be such an interesting mix of what's going on in the next couple of years. And what worries me is that everybody starts buying all these tools, and then a couple of years, we're going to have so much integration debt that I mean, that just scares me. I don't know how we're preparing for that.
Yeah, no, totally. I agree with you. I mean, I think if you look at any new industry, whether it's like financial industry or whether it's like car manufacturers or oil producers or whatever, you start out with like 1,000 companies, and then like over the years, like there's like fewer and fewer left, and hopefully you end up with more than one in the end, because that I think, but usually what you end up is like some sort of stable oligopoly, like two, three, four vendors. That's what you see in the cloud market. I mean, cloud has like economies of scale, like I think more so than maybe data tools. But I mean, I think any industry you look at, I mean, airlines, like whatever it is, like you end up with like 3 to 4 or 5 companies that control 80% of the market in the end.
So that's really what's going to be. Is it the market companies around metadata, around data management, around workflows and moving the data infrastructure, some stuff around analytics? Those are 4. I mean, I don't know.
No, I think they're going to be like more like vertical companies. It's going to be like, cloud vendors. Like, you buy into this cloud vendor, and then you get the metadata management, you get the workflow engine, you get the runtime, you get the query engine, you get the ETL, like you get all of that. But like you have to pick one. Like you have to pick one of these verticals.
So that but that's kind of happening now. I mean, if you look at you got AWS and you got Azure, Microsoft,
But
and
Eric, are you saying like you're gonna be like, oh, we're on the Snowflake stack or we're on the Databricks stack, and like that all of a
I think
sudden
so.
means a bunch of stuff?
I think so. I think I think to some extent, like cloud vendors, when I look at them, I actually feel like they're somewhat like exiting the software and like focusing more on like the running of data centers and like focusing on the lowest layer of it. And then like the software layer above, that's where like the battle is right now. And like you said, I think there's going to be a Snowflake. I think there's going to be a Databricks or like whatever it is. Like, I don't know. But like that's what I think is going to end up with. Like there's going to be a few players, above the cloud vendors. And maybe you can use like any cloud vendor with any like data provider. Like, I don't know. But like I think there's going to be sort of a consolidation above the cloud vendors into different layer. That's like the analytics stack or whatever.
yeah, this is interesting. This is the Snowflake, the modern data warehouse, the modern data stack per Snowflake of the Databricks, right? There's going to be different, and this can run on different types of engines. So yeah, this is we're trying to kind of predict the future here, which we have no idea about. So how about we switch a little bit onto another topic, which is I've been meaning to ask you is on people, on teams. So, okay, so you kind of dodged the modern data, Erik's modern data stack, ideal preferred data stack. So here's another question, which is, what does an ideal data team look like?
Yeah. I mean, I feel like maybe you're like, referring to like a blog post that I read like a few months ago, or like I've been sort of tweeting about this, but like generally, I think I'm like kind of anti-specialization, but like I also like, so like to a large extent, like I think, number one is like I am a general believer in like pretty like wide skill set, which today is very hard because I think the data stack is like so complex. So it's like kind of hard to find someone who's like knows machine learning and knows business intelligence and product analytics and also knows like software engineering and infrastructure. Like but I think that doesn't sort of mean the point isn't true, which is like the more general your team is, like the easier that it gets to coordinate things. So I don't know, like that's sort of more like a general point that I try to when I build data teams, and is to hire people who are decent at like everything, and above all like quite commercial. I think there's just so much over focus on sometimes what I think of as like mathematical rigor. I like, by the way, I studied physics, like I'm like, and I have like a deep math background, but like the truth is like really what like it looks like out there when you're like, I'm mostly talking about startups now, when you're trying to build a data team, is like so much of the value in like doing data is going to be building internal data sets and then like finding like obvious stupid things the company's doing in those data sets. So like you're probably not going to need to train any advanced machine learning. Like you're not even going to have to train any machine learning.
Can you say that louder?
You're not going to have to do machine learning. I think like like you're going to find some if your mindset is like you're a journalist and then you're going to find the scoop, like you're going to find some like nasty stuff going on at this company. And and by the way, the company culture is like ready for that, because I think that's a separate thing. Is like sometimes company cultures are not ready to accept that there's like dumb things happening. But if you get to that point, then a lot of stuff is going to be a SQL query and a scatter plot or whatever. And then, you're going to like find something like so embarrassing. Like you're going to find that like 50% of people drop out on the third page of your onboarding form because like your email validation logic is broken, or like something like terrible like that. Like I may be hyperbolic a little bit, but like I think to me, like that's always been like where I've seen the most value of data is like, finding these like painfully obvious things the company's doing a bad job at.
You're talking about like that whole journey of descriptive analytics to prescriptive to predictive. You think about like like a lot of companies can get a ton of value from the descriptive analytics and aren't even doing enough of that already.
I think so, and I think maybe there's a little bit of like a wishful thinking. They're like, yeah, we're already doing so much, cool, like like we're doing everything so well already. What we need to get to the next level is like AI. We need to like do this like deep learning and like whatever. Like that's like how we get to the next level, and then kind of like admit the fact that like no, like I don't know, like have you used some like try to sign up for like, I don't know, cable TV or like whatever, car insurance or whatever. And you're like, oh my God, this is like so confusing and like so bad. And like, I have, I strongly doubt that there's anyone on their data team that's looked at the conversion funnel metrics and like really like instrumented everything and like known every point in the dropout, like in that journey, like how, where customers run into friction or whatever. On the other hand, I think those companies have all invested in like AI. And I don't know why, because like they have like stupid things going on in their, in their web experience. Like fix that first. Like
I truly appreciate this conversation right now, because this is the honest, no BS stuff that you hear all the time. These companies are investing millions of dollars in the last 5, almost 10 years in creating data science teams to go do all this stuff. I'm like, you've put in so much money in this. How much have you actually returned off that investment? And by the way, you still have all these little shitty different problems that you have on your website. That's the true problem, that like any normal person could have gone and figured that out without having to go spend millions of dollars in some data science team to go do some fancy AI that is not actually providing value. I mean, the market, the pundits are all talking about AI. I have to have a team of data scientists. I got to do AI stuff. And no, you don't. You got to go look at the basics. And this is the stuff that people are not realizing. And this is such a frustration. And they have a checklist. I need to ask if we do AI. So don't do it. Let me go do something. And I can see myself busy. Like, I'm totally with you on this. And there's just so much BS out there.
there's so much stuff in the world where all you need is a SQL query and a scatter plot. Like that's it.
Well, it seems like there's a lot of right. And a curious mind. It seems like there's a lot of misunderstanding in general around data and the world of data. And I want to think that like a lot of people in positions of leadership in different organizations think that maybe their data pipelines are okay, and maybe that they do. Oh yeah, we've had Teradata for a long time or whatever, right? And they're like, now the next step, right? The next step is AI and machine learning and all those kinds of things, not realizing that they don't have the foundation yet.
I think that's right. I mean, AI has become a checkbox that you tell investors in your company, like on your quarterly report. You're like, yeah, we're investing $100 million in AI, so we're going to be great. But like, no, because like who cares about your chatbot? Like, fix all these like stupid bugs in your like product instead. Like, maybe you should invest $100 million in that.
We need to have an after party event where we just talk about chatbots and complain about that. That would be fun.
Yeah.
I mean, yeah, chatbots. That's another thing. Everybody's doing them, but no. This is the honest, no BS. But okay, so going back to teams. So you're more of a generalist. How about something I always ask people is on the balance between centralization and decentralization. So should you have generalists who live on a centralized team in charge, or decentralize this? Like, what are your thoughts based on your experience?
I've found that both extremes are quite bad. And, because let's talk through it for a second. Like centralization, I ran a centralized data team for a while. The problem with centralization is like, you're just going to create like so many people throughout the organization that are just mad at you because they're like, I just need help. Like I've asked them like 5 times, like, I just need someone who can like tell me, what's going on in the data. Like just, and like feel like nothing's getting, like you're basically creating this like gatekeeper team internally that's sort of controlling the backlog, and no one's going to be happy with that. the problem with extreme decentralization, on the other hand, is like, let's say, okay, you tell all these like business people, like, just go out and build up your own data teams. They're not going to have any clue what to look for. So they're going to end up hiring like, probably not the best people. And then those people are not going to be, their managers don't really know what they're doing. So they're not going to get the feedback they need, and they're not going to grow. And, and then they're going to leave because they want to go somewhere else and work for someone who actually knows what they're doing. And so I think decentralization, maybe it's a little bit better on average, actually, but I think still it's like not great. So I think, the only sort of model that I've come to like, endorse is really some sort of hybrid model. And it sort of pains me to do that because like generally I think sort of matrix models are like quite bad. I find like experimenting with a lot of matrix models. I spent several years there, and overall I think they're quite bad and should be avoided. But I think in this case, like there is enough of an argument for the benefits of doing that. So what that means is like you have a centralized reporting structure. You have a data team, with a strong head of data or whatever, strong set of individuals who know how to hire. They have internal tools, like they have internal standards. They know what good performance looks like. They know what bad performance looks like. And then you have all these like data scientists or data engineers or whatever who actually spend most of their day working with business people or product teams or, whatever. And, on a day-to-day basis, like their backlog is kind of driven more by what those teams need. And I think that's like really the only, there's a couple of other things that sort of resemble, like design tends to be the same thing. QA tends to be the same thing. There's another couple of engineering. I used to be a CTO for many years, so I thought a lot about this. But generally, other than that, I wouldn't recommend hybrid models for many other types of jobs. But I think data is one of the professions where it actually makes sense.
Right. This is something we agree with. I think the two extremes is something that definitely, those won't work. And you bring up something interesting, which is like if you're completely decentralized, like these folks don't even know how to go hire people, right? They're not going to go hire the best people anyways, and they're going to go leave. So that's another interesting point right there. Look, time flies. This is we can keep talking, but we need to start wrapping up, and we got some lightning round questions here. I think we're ready, and the lightning round questions are going to bring up some topics that we wanted to talk about, but we'll leave them for the next one. I'll kick it off. All right, first one. Do you think this no-code, low-code programming is a legitimate trend? Yes or no?
Yeah, I think so, with a lot of asterisks, but I think yes.
This also came up a little bit in our chat today, but will companies like Snowflake and Databricks, so this sort of the data stack, data layer, do you think that'll sustainably stay separate from companies like AWS, Google, and Microsoft?
I think so, because I think to kind of what I mentioned earlier, I think the cloud vendors, and this is maybe a longer thing, I could write a whole blog post about it, but like I think about like what they're good at is like running data centers. And that's a very different type of business than running software on data centers. And so I think increasingly we'll see a layer above, with companies like Databricks and Snowflake who are writing the software, and AWS specializing more in offering the hardware.
So we talked a lot about the business logic and where it should be. We didn't talk about kind of data modeling and semantic layers and stuff. So question is, is the semantic layer or the data modeling layer, is this still a big missing piece?
Maybe. I don't know. I think so. Like I don't know what like if you're talking about semantic web, I don't think so, because that was always like a weird thing to me. But I certainly think there's like more tooling. People talk about data mesh. I feel like it's kind of like weird and like I don't really get it. But like I do think there's something there around like, okay, you have a lot of data sets. Like how do you classify them? Like who should have access to what? Like what do they contain? Like what's related to what? And like what's clean enough that you can use it for certain things, right? So maybe that's like sort of catalog in a way that I'm talking about.
All right,
interesting. I'm hearing a mostly yes there, but that's interesting. And when you talk about the hybrid model, I hear mesh there, but it's interesting. Your the way you talk about mesh.
I think the problem I have with mesh is like mesh is also like it could be anything. And so my worry about mesh is like all these like companies are going to look at data mesh and they're going to be like, yeah, we have databases all over the company, like a lot of different data warehouses. That's data mesh, right? And then like, some consultant is going to, charge them, send them $100,000 invoice to say, yeah, that's really good. That's the data mesh.
Yeah, I think that's a good thing to be worried about. Like when a concept becomes more about the concept as opposed to like what it's actually trying to explain and represent, right?
Right.
All right, last question for lightning round for you here. So this analytics engineer concept obviously is becoming more of a thing. Do you see analytics engineers, versus data engineers or analysts, as a legitimate role, something that's going to last?
I don't know. I think that, generally, I think we should have fewer roles. I think data engineers are even like data engineers, I think, should go away. Because if you think about it, like data engineers are not doing any business logic. And so, I used to be a data engineer for many years. Like I think, at many companies, like you should of course hire data engineers. But I think in the long run, there's almost like, the goal of a data engineer should always almost be to make yourself useless. And I think, through better tools and better infrastructure, we're probably going to see less data engineers. Analytics engineers, like, I don't know. To me, like an analytics engineer is like kind of the same thing as like data science. Like, I don't know, like, maybe it's the same thing, maybe it's not. Like, I think we're sort of pushed into specialization that maybe we shouldn't, pursue. But I think, if it's data scientist that should go, or analytics engineer that should go, or maybe we should, analytics scientist, or I don't know, whatever, whatever we end up calling them, like I almost don't care.
Yeah, that's a very honest statement, by the way, about we love specializations. I think as an entire industry, and we even have a couple of specializations that we like data product managers, for example. Knowledge scientists is something that we talk about. There was actually an interesting thread on Twitter, and Eric, I don't know if you were part of this. You may have jumped in on it about this sort of increasing role of SQL in the stack, and how somebody on Twitter was talking about how um, they're seeing more and more data engineers actually becoming sort of seeing that their role is getting shifted a little bit away from the infrastructure and the code, non-SQL code, and into more of the SQL stack and things like that, right? Things like DBT and that sort of thing, and that a lot of data engineers are actually looking now to move back into like back-end software engineering and things like that, and now like the analytics engineers are kind of like the new data engineers. I don't know if that has any legs or not, but it's a very interesting thought.
I think that's true, and I think, maybe that's a sign that, data engineers are done. Like maybe we like, mission accomplished. Like we built the tools we needed. Like now let's move on. Hopefully, analytics engineers, like, in the long run, like maybe there's something similar. I don't know. Maybe they mutate into data scientists. I don't know. But I think you're saying in a way like same thing as I just said.
Right.
I think, I don't know.
Yeah, I think so. It's moving up stack, right?
You both are in agreement here. So, hey, it's our takeaway time. Tim, take us away with some takeaways.
Yeah, sure. Two key concepts, Eric, that I really appreciated and took away from this conversation are when you said at the beginning, let people use whatever tools they want, and in the end, adoption is what is good. The tools that get adopted are the ones that people are using, and those are the ones that will stick around. I thought that was kind of a good way of thinking about it. And when we started talking about the bad stuff, you had started talking about infrastructure, and it actually kind of comes full circle with the comments we just had about data engineering, which is that it seems like, a lot of data work traditionally and still is this sort of the pushing and shoving and shoveling of data, right? And the more we can start to get out of the shoveling of data and the shoveling of cloud machines, and the more we can focus on business logic and business questions, it seems like that's good. That's good momentum. That's good movement. And there's too many boxes. There will probably be fewer boxes in the future. There will be consolidation. There needs to be consolidation, but there's a couple of things to watch out for in terms of openness and in terms of like price gouging and things like that, right?
I think that's right.
What about you?
So
go ahead.
There's this big theme around connecting things to the business. I think this is what you just said right now, that for the data engineers, like they're going to get like they should not be involved. They should get out of a job and they should be providing value. And that's kind of the stuff more in the business, where the business logic is. I think we talked about like these declarative language. A SQL is that important for the business logic. And I think we agree that higher level abstractions are better. There's this test of time of what's actually going to be good are things that have been around for 50 years. They'll continue to be around, right? Like you said, SQL and C was the one, right? Um, and one very important thing you said, what you need is SQL queries, scatter plots, and a curious mind. Love that. Hey, Erik, back to you. Thank you so much. What's your advice and who should we invite next?
Wow. What's my advice is keep a curious mind, write SQL queries, and scatterplot. I don't know. I think my biggest advice is think about what the business needs, because I think that like so many people get excited about tools and they get excited about like specialization, and like I think people sometimes forget about like, okay, I'm actually here to like build a successful business. And I think that's always been my best career advice, is like every morning come in with this sort of perspective that like, what is the biggest value that I can add to the business today, and then kind of do that.
That's great advice.
Who to invite next? So I was gonna say Sarah Catanzaro, but I sounds like you're already talking to her, so now I'm like drawing a blank.
No, okay, great. I mean, that's fine. I met her. I finally met her in person today because she was here in Austin. So I'll make sure that she listens to this and have her know that you called her out. So awesome.
Cool.
Erik, thank you so much. This was an awesome conversation. So many good, I mean, some very wise things have been said here. A lot of things to go back. We appreciate it. Cheers.
Cheers.
It's fun.
Cheers. And next week we have Cindy Housen, who's a Chief Data Strategy Officer at ThoughtSpot and the host of the Data Chief podcast, one of my other good podcasts I like to listen to. So stick around. Have a great Wednesday. Thanks again.